Yes, class. Am I audible to all of you? Alia, Austin, Deborah, Fia, Humam, Madiha, Tarif, Rajita, Shahid. Right. Faiza is joining. See, class, in the last class we had completed, yes, that portion was completed, no, formation of images of concave and convex mirror. Fine. Now, this is one derivation that will come in your exam. See, an array is incident. Fine. This is incident ray. This is the incident ray. This is the incident ray. See, suppose this is A point, this is B point at which the ray has struck the mirror. Now what will happen? All the laws of reflection will be obeyed. So here, this passes through the center of curvature. This is also one of the properties of the mirrors, that whenever you drop a normal, how will you draw a normal? This is a curved surface. So just, this is a trick to remember, that join the point to the center of curvature. That will give you the normal on the mirror. This is the normal of the mirror. Now see, so this is, if this is the normal, this is the incident ray, this has to be the angle of incidence. Now what will happen? The reflected ray will be passing through the focus. Let's say this point is the focus. So the reflected ray is passing through the focus. So this is what? This is the reflected ray. So the angle between the normal and the reflected ray, this is known as angle of reflection. Fine. So angle of incidence, angle of reflection. Just for the derivation purpose, I am taking this angle as alpha. This is nothing. This is a random angle that I have taken. It's just that I will be needing this in the derivation. That's why I have used it. So from the pole to the focus, in the first class only, I told you that this is known as the focal length. This is the focal length, that is F. Fine. And this entire part till the center of curvature, this is the radius of curvature. Now see, class, according to the laws of reflection, according to the first law of reflection, we had studied angle of incidence is equal to angle of reflection. This is the first law of reflection. So laws of reflection. Fine. According to the laws of reflection, we know that angle of incidence is equal to angle of reflection. Class, look, this incident ray is parallel to the principal axis. If this angle is I, this angle is alpha. Can you see both of these are alternate angles? It's like two parallel lines are present. One angle is present here. One angle is present here. This is angle of incidence. This is alpha. So both of these angles, these are alternate angles. Fine. These are alternate angles. So angle of incidence is equal to alpha. Angle of incidence is equal to angle alpha. Why? Reason is that they are alternate angles. Now, if see, angle of incidence is equal to R, I is equal to alpha. So according to this, if both of these are equal, then they should also be equal. Angle R should be equal to alpha. Now look, in this, the triangle CBF, this triangle. See, if these two angles are equal, this makes it an isosceles triangle. So what is the property? If two angles are equal, their opposite sides also have to be equal. It means CF is equal to this FB. Both of these are equal. Why? See, this is this triangle. Alpha, this is I. So if these two angles are equal, their opposite sides are also equal. So you can say CF is equal to BF. Now see, if you till here this is clear. Now see, if you take a very small aperture of the mirror, then this difference that arises, this difference, FP and this FB, both are almost same because the incident, the aperture is so small that this separation is very small. So you can say this separation and this separation both are almost similar. So if for small aperture we can say BF is almost equal to FP. So CF is equal to FP. It means we can say CF plus FP is equal to R. What is the radius of curvature? CF plus FP. See, this CF is equal to FP. How? Because of opposite angles, these were already equal. CF was equal to FB. And right now, FP is almost equal to FP. If both of these are equal and this is equal to this, it means you can say CF and FP both are same. Clear? CF and FP, both of these are equal. Why? Because these opposite angles were equal. Firstly, we started the derivation with the fact that I and R are equal. Then I and alpha are equal. Since they both are equal, they will also be equal to each other, R and alpha. And if opposite angles are equal, opposite sides will be equal. Opposite sides are equal. Also, this side and this side, because of the small aperture of the mirror, they are same. So they also become same. That is CF plus FP, which is equal to R. You can see here, I can write it as 2 times FP is equal to R because CF is equal to FP already. So FP will be equal to R by 2. What is FP? FP is the focus. Focus is equal to radius of curvature by 2. This is a formula also which you people have to remember. And this is the first derivation of this lesson also, which you all have to remember. This, you should remember this. All the question will be solved by the starting part. First, equate both the angles. I and alpha both are equal. So if both are equal to angle I, if angle I is common, then you can say angle R is equal to angle alpha. And if both of these are equal, then in triangle CBF, this becomes an isosceles triangle. So you can say the fact that CF is equal to BF and rest of the derivation. Note it down. First write down this and please mark it as important. This does come in your exam. Small aperture means, see, in the first class I told you, know what is meant by aperture. Aperture of the mirror is this. This is the linear aperture. This is the angular aperture. So aperture means this curvature part. If I tell you this is a very small aperture. If I tell you this, see, this is a very large aperture. So that is what is meant by small aperture of the mirror. R is, yes, R is radius of curvature. Focus is half of radius of curvature. That is only what we have proven. We have proven this only, that radius of curvature is basically double of the focus of the mirror. Now coming to the derivation of the mirror formula. So mirror formula is very easy. The formula is basically 1 by f is equal to 1 by v plus 1 by u. That is the formula. Now to derive this derivation also comes in your exam. So first we have to draw the figure. So again, we'll follow all the three laws which we have studied. First law was when the ray of light strikes the surface, it passes through the focus of the mirror. So this is the focus, this is passing through the focus. This is the focus, this is the center of curvature. Oh, forget this, the center of curvature is here. Yes?
We'll be doing, we did like formation of images by concave mirror. We won't be doing with convex mirror because we did only one thing, like in front of the mirror.
So what is the another case that is possible here?
Behind the mirror.
How can you keep the object behind the mirror? If you are keeping the object behind the mirror, then this is silvered. Where will the reflection go? I told you this in the last class also. Yesterday I specifically mentioned that in convex mirror you only have one case. Reason is that in front of the mirror you can keep it anywhere, that will be just changing its shape. Here you keep it here, you keep it here, you keep it here, anywhere this will be in front of the mirror only. Behind the mirror you cannot keep the object. Where will the rays go? When you have silvered this part, for reflection you need this mirror, no fear. Otherwise, where will the reflection occur? Where will the bouncing back of light occur? So that's why convex mirror, we just have one case because that is in front of the mirror. All the landmarks are present behind the mirror. So we need not keep the object over here. Reflection won't only occur. You cannot keep the object behind the mirror.
Okay, thank you.
Okay, so yes, rays of light were falling. So one was that this will pass through the focus. Again, class, I'll tell you, please draw it properly in your notebooks. You will get proper images. Then second is passing through the center of curvature. This is the center of curvature. In the notebook even also, not just for the screen, when in the notebook also, when you will be drawing this difficulty, you will be having the rays will not be exactly meeting. So what you do, obviously you will be drawing the rays with help of pencil only. So like this, the way I shifted the center of curvature, or center of curvature has to be constant, at least the height of image and all, just to coincide it. This you can do because in the notebook also sometimes this does not match. Last one is, last formula is striking of the mirror. Then what happens at the same angle? This came, this retraced itself back. This is coming. So this is obeying the rule here. Like this. This is the angle of incidence. This is angle of reflection. Fine. Now, where is the image forming? Image is forming over here. All the rays are intersecting A dash, B dash. Fine, A dash, B dash. You have this entire as the radius of curvature. This the focus. Fine. So ray diagram we have drawn. Now, object distance. This entire separation from this to this point. See, this entire separation from the pole of the mirror where the object is kept is known as U. U represents the object distance always. Now see, remember the sign convention. When anything is against the incident ray of light or kept in front of the mirror, we take it as negative. So here U is also taken as negative object distance. Where is the image formed? Image has been formed here. So this separation from the pole of the mirror to this image, this is V. V is the image distance. Again, this is also formed in front of the mirror, so we have taken it negative. This is focal length minus F, and this is radius of curvature. Since in this figure, everything is kept in front of the mirror, so we are having every quantity as negative. So whatever it is, we have to substitute it like this only. Now see, two triangles we have, if you look here carefully. Triangle ABC. This triangle ABC. And this triangle, small one, A dash B dash C. They are similar triangles. How? Look, this angle, both the angles are same vertically opposite angle. This is 90°, this is 90°. So AA property, both the triangles are similar. In class 10th, you must have done similarity of triangles. So triangle ABC, this is similar to triangle A dash B dash C. When two triangles are similar, we can say A dash B dash by AB, A dash B dash by AB is equal to CB dash by CB. This is not what is meant by equating similar triangles. AB by A dash B dash is equal to BC by B dash C is equal to AC by A dash C. All of these become similar. All those who are not able to recall this, please revise your triangles lessons from your class 10th in NCERT book, whichever textbook you have. If still you are not able to understand, let me know, I'll repeat it. So A dash B dash by AC, A dash B dash by AC will be equal to B dash C by BC. So this is CB dash by BC. Now, what is this further equal to? See, what is CB dash? CB dash is ultimately, see, the CP minus B dash P. Look, this is CP minus PB dash. What is left? CB dash. From this entire bigger one, if you are subtracting this smaller one, you will be left with CB dash, right? So you can write this as CP minus B dash P divided by. What about BC? See, from this entire BP, if I subtract this CP, I'll be left with BC, right? So here, CP minus B dash P divided by BP minus CP. Now, what is CP? Look here from the figure. CP is actually the radius of curvature. So, minus R. Then this minus sign. Then B dash P. B dash P. This is the image distance. Image distance from the pole. So, distance of image from the pole, this is minus P divided by BP. BP is the entire separation from object, U. So, minus U. Minus, again, CP is minus R. So, you are left with, this is minus R plus V divided by minus U plus R. Why did you understand? CP was minus R, B dash P was minus V, BP was the entire separation U. That's why we did this. Also, this is using the triangle A, this bigger triangle and this smaller triangle. One more triangle we have obtained. One more. We did this. Why was this necessary? By these two rays only, by the center of curvature one and this infinity to this parallel and focus, when we were already getting intersection, why did we just do this third one also? We obeyed the third law also. Why? The reason is that if you look at this triangle APB and this one smaller one, A dash B dash P dash P, A dash B dash P, this smaller inverted one, and this bigger ABP. You can see, this angle is this angle, both are equal. This side is common, this angle, both of these angles are same, I and R. So ASA, angle side angle property, both these triangles are also similar. So you can say in triangle A dash B dash P, this is similar to triangle ABP. So A dash B by AB is equal to B dash P by BP. So B dash P was minus V. BP is minus U. So this is equal to V by U. So A dash B by AB is equal to V by U. This is second equation. So what is the first equation? A dash B is equal to this. It means both of these are ultimately, both these terms, they are ultimately equal to A dash B by AB. So you can equate both these. So minus R plus U by minus V plus R is equal to V by U. Now take the LCM. This becomes minus UR plus UV is equal to minus UV plus VR. So VR plus UR is equal to 2UV. Now what we do, if you divide this entire equation by UVR, divide by UVR. So see, VR plus UR is equal to 2UV was there already. Divide this by UVR. 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 So VVRR get cancelled. UURR get cancelled. UV are cancelled. So what are we left with? 1 by U plus 1 by V is equal to 2 by R. We have just done a derivation before this one. Before this derivation, we had another derivation. So R by 2 is equal to F. Here what we have? Here we have 2 by R. So 2 by R will be 1 by F. So 1 by F is equal to 1 by V plus 1 by U. This is the formula. This is the focal length. V is image distance, U is object distance. And please use sign convention when you are putting the values. If an object is kept 10 centimeters in front of the mirror, substitute this as minus 10. Fine. So use sign convention, proper sign convention. Fine. Write it down, this entire derivation. See, for the derivation of linear magnification, this is in continuation with the same figure. So I'm not repeating the figure. You just have to start from this step. See, triangle APB, we equated it to A dash B dash, remember? So from here only, this step we wrote A dash B dash by AB is equal to B dash P divided by BP. So this step will be the same. From this step, you have to now just put in the values. See, A dash B dash we never used. AB we never used, right? Also, we used B dash P, that was minus V. And we used BP, that was minus U. But A dash B dash and AB we didn't use. What was A dash B dash? And what was AB? AB was the height of the object. Look, this is height of the image. So this is height of the object. Now see, height of the object, this is kept in front of the principal axis. So AB is positive, but the image that is formed is negative. So minus HI. So look here, put all the values. Minus height of image by height of object is equal to minus V by U. So linear magnification is equal to height of image by height of object. This is the actual definition of linear magnification. It's the ratio of height of image by height of object, which is further equal to minus V by U. Why minus? Because this negative sign. This is what you have to remember, what is important. Now look. See, ratio is basically definition is the ratio of height of object to that of height of image is called linear magnification. There are we talk about transverse magnification over here, which is denoted by the letter M. Also, if you substitute this V by U in the formula, 1 by F is equal to 1 by V plus 1 by U. If you use this, then you get the value of V by U from here. So you will basically get a magnification equal to F. If you substitute the value of U, you will get F minus V by F. If you substitute the value of V, you will get F by F minus U. These are two more formula which can be helpful if sometimes it is needed, but otherwise this is the formula that you have to actually use. Now, how will you interpret things? This slide, no, which I have kept right now, this page, this is very important. See, magnitude, if you are getting, that will define whatever is the size of the image. Suppose magnification is coming greater than 1. Magnification's magnitude. And when I say magnitude, you have to ignore the sign. -3, +3, it doesn't matter to you. When I'm saying magnitude, it means just the number 3, be it minus or plus. Otherwise, if you will go by the number line, your entire question will come wrong. So see, magnification greater than 1, image is magnified. If it is less than 1, then image is diminished. If it is equal to 1, then image is of same size. Suppose if I tell you -3, so 3 is what? 3 is greater than 1, so image is magnified. If I tell you magnification is 0.8, so 0.8 is less than 1, that is diminished. Fine. Now, but what about the signs then? Because you will never get the answer without the sign. Either positive will be there or negative will be there. So whenever you will have positive signs, that will show that image is virtual and erect. And whenever you will have negative signs, that will show image is real and inverted. So for example, if I say, tell me the details about the image formed with magnification minus 0.75. Firstly, magnitude. Magnitude is 0.75, less than 1. So image is diminished. Minus sign shows image is real and inverted. So real and inverted image, which is diminished. This is the detailing. This is the detail about the image. Likewise, you will first calculate magnification whenever questions are asked about the detail, and you will use this to find out the detail. So magnitude first. If I tell you magnification is -1, that means 1 means same size, minus means real and inverted. If I tell you magnification is +8, such a huge number. So 8 is image is magnified, plus sign is virtual and erect. This is what you have to use, and this is a very, very easy and very important method for all of your usages. Continue from here, linear magnification. All those who have completed, you can leave now. Next week, we'll continue this.